Okay, 10.3. We're still dealing with measures of central tendency. And the very first thing that they look at in 10.3 is it talks about the range of data. And the range is really simple, really straightforward. It's the high minus the low. Find the highest number in the data, find the lowest number in the data, and then subtract those two numbers, and that's it. The other thing that they start talking about is deviations of the mean. And they talk about some of the things that's the deviations. And they talk about a lot of different things in section 3, but they really key in on 2 or 3 main things here. But really, deviations from the mean is just a way to kind of have some way. Basically, you're going to do this. You're going to subtract the mean from each number in the distribution. And it's almost kind of a built-in way to kind of check on this one. So when you're doing this one, some of your numbers will be negative, some will be positive, just depending on how it's set up here. The one thing that's kind of a check is that the sum of all your deviations is going to equal 0. Because again, the mean should be, the average is in the middle of the distribution that you're looking at. So when you compare the low numbers and the high numbers, it's always going to kind of even itself out. And so with this, since the sum is always 0, people were trying to figure out some different things to do with it, and they couldn't work with the sum. So they're like, okay, well, just a regular deviation doesn't work. So then they came up with what they call a standard deviation. And with standard deviation, this is going to take you back to basically a curve. It's the bell curve, the normal curve we were looking at back in section 2, I think it was, maybe section 1. So this is kind of where it's going for on this one. The standard deviation is basically when you have that bell curve that's here. It separates everything out. That once you start from the middle, if you go one space to the right or one space to the left of the middle, they call that one standard deviation. So you've got a big chunk of your data that would be here. And then if you move 2 steps out, then you've got another chunk of data that's here. And so that's what standard deviation is basically saying, all right, if you start from the mean and work your way out, how much information can we get from this one? And this is where standard deviation kind of comes in on this part of it. So with standard deviations, you're going to do basically 3 things here. First thing is you're going to find the sum of each deviation squared. So you're going to take the deviations from the mean that we had here. We're going to subtract the mean from each number. We're going to get whatever that number may be, and then you're going to square that number. And once you square that number, you're going to do that for each individual number on the list, and then you're going to add up what that total would be. Squaring it takes out the negative, so it takes that part of it away from it. The second thing is you're going to divide by n minus 1. And then the last thing you're going to do is you're going to take the square root. And depending on the calculators that you do, a lot of times on these, you can do them different ways. It's almost easier when I'm doing these to kind of set this thing up is that when we've got this sum that's here, is to go ahead and find out what this sum is and then do the square root of that sum divided by n minus 1. It works out a little bit easier with the calculator depending on which calculators you have. And again, if some of them are set up a little bit different. So just depending on the numbers and how you set those up, then it'll be different things for these. So, okay, so here we go. Let's just kind of give you some problems on these and just kind of go from here. So, kind of roll in both of these two parts together. This is really the main two things that they have. They talk about the range and the standard deviation. There's another one where they've got a question that kind of spins off of something that's in the standard deviation, Chebyshev's rule, but we'll get to that in a minute. So, okay, so we're going to find the range and the standard deviation, and we're going to give you this set of numbers. Okay, and again, range, pretty straightforward. Find your highest number, 78. Find your lowest number, 19. Subtract those two, and then your range would be 59. Okay, to find the mean, add all these numbers together. Let's see what we get here. So that is that is 220. We've got 1, 2, 3, 4, 5 numbers. So 220 divided by 5 should be 44 for the mean. And depending on the problem, sometimes they'll ask you for range, sometimes they ask you for mean when you're working through this one. So they may ask for a bunch of different things when they go through these. But that's really about the only two they can ask for, is range or mean before they get standard deviation. Okay, so here's where standard deviation, here's what we're going to do. We're going to take each, and you almost kind of have to do these by hand. We're going to take each score we got, 19 minus 44. That is negative 25. We've got 25 minus 44 is negative 19. 64 minus 44, which is 20. 34 minus 44, which is negative 10. And then 78 minus 44, which is 34. Okay, and then you're going to take each number and square it. So we're going to do negative 25 squared plus negative 19 squared plus 20 squared plus negative 10 squared plus 34 squared. Okay, so we're going to take all these numbers that we have here, put that together. Get the sum there. That is 2,642 when we add all those numbers together. Okay, so again, step one, you're basically going to find the mean. Once you've got the mean, you're going to subtract the mean from every number that's in that distribution that you have here. And to get rid of the negatives, they square those numbers, and we're going to find that sum that's here. So we've got 2,642. Last step is, and here's where I would kind of go, this is what I would do for calculators, depending on which ones you have. Once you've got your sum of 2,642, we've got to divide by n minus 1. Well, we had 5 numbers, so that's n minus 1, so that's 4. If you're on the calculator, it's hard to, if you've done that squares and you've got the numbers that's here up to this point, it's hard to kind of get that number there, depending on the calculator. So this is one it's almost better just to start over. So I'll just do square root of, and again, depending on your calculators, this one has a fraction button. So we get out of the glare so you can see it there. If you don't have the fraction button, you can just do square root of, and then do parentheses. And then you can do 2642 divided by 4, close off your parentheses. You can see that very well. So that's, most calculators, that's probably your best option. Let's go back and do something like that. If you've got the fraction button built in, that's great. If you don't, that's kind of your backup plan to go for those. All right, hit equals, and that comes out to be 25.7. Depending on what they ask you to round it to, they may ask you to go to 1 or 2 or 3 decimal places or whatever that may be. Okay, and for standard deviation, they say that's just equal to S. Usually it's like a little script S of some kind. All right, any thoughts, any questions on that one? All right, let's do one more of those. I'm just going to list these down the page just to make it a little bit easier as we're working through these, a little easier to see. So 98, 112, 127, 141, 146, 151, and 184. Also going to go ahead and put these in order just to make it a little bit easier. Okay, range, that is 184 minus 98. Comes out to be 86. For the mean, add all these together. That's 98. Gives us 959. There are 7 numbers. Do 959 divided by 7. Comes out that the mean is going to be 137. Okay, so then for standard deviation, again, we're going to take the mean that we have, or take each individual score we have, we're going to subtract the mean from that. So that's minus 137. Okay, so this comes out to be negative 39, negative 25, negative 10, 4, 9, 14, and 47. And for standard deviations, we're going to take each of these numbers and square it. And then we're going to add all that together. Okay, and ran these numbers a little bit ahead of time to save us a little bit of work. So once you've got all these numbers, you can take each individual score, subtract the mean, take each of those numbers, and then square it. This comes out to be 4,748. Okay, and then we're going to square root the sum of the square differences. There were 7 numbers, so when we go to this one, we're going to divide it by 6. For this one, we'll round this one off to 2 decimal places. This should come out to be 28.13. Okay, and that is really the one. If there's one big thing, that's the one big thing that they look at in section 3, is just how you do standard deviation. I think there's 12 questions, and probably 6 or 7 of those will be standard deviation. So once you kind of get the hang of it, it's just, multiple steps, multiple processes of going through and just practicing on those till you get there. The only other thing that's in section 3 is what they call it's Chebyshev's theorem. And there's a couple of different ways you can kind of spin off this one. It still deals with standard deviation. Basically is this. We'll do 2 examples here. We'll spin off the second example. Will basically spin off the first one here. Chebyshev's theorem. Again, this is all spinning off of standard deviation here. For a set of numbers, it says the fraction of numbers that will lie within k standard deviations of the mean is given by, and this is the one formula that you always come back to, 1 minus 1 over k squared. Yeah, and both of the examples that we're going to do, and it's almost, probably should have had this as like the beginning of the problem here. So here would be example 1, because we'll use that same setup for example 2 on this part of it. All right, and pretty much there are only a couple of different options of what they can do for these. Example 1, we're going to say find the fraction of students or fraction of numbers that lie within 3 standard deviations. Okay, so for this one, again, this is basically your setup. Chebyshev theorem is always the same thing. It's 1 minus 1 over k squared. This one, they're telling you that your 3 standard deviations is here, so it's just 1 minus 1 over 3 squared. What's 1 minus 1 over 9? If you convert that into a fraction, make that 9/9, so that you can subtract, then you'll have 8/9. Okay, so if they tell you how many standard deviations, pretty straightforward. Just take that number, plug it into the formula, and then you get to work it out from there. Okay, the second problem that they can do based on that same type thing, and we'll just kind of cover that one up because example 2 will run with that same setup. Okay, so this one's going to kind of change gears a little bit. Instead of giving you the standard deviations, this one gives you all the information that's here. It's going to say within a certain distribution, the mean equals 90. And has a standard deviation. We'll just abbreviate on that just to make things go a little bit quicker. Of 6. And the question is going to kind of change gears a little bit. What percent of the numbers are between 72 and 108? Okay, I'll get rid of that because it's pretty. Don't necessarily need that anymore. All right, so for this one, you've got to find out what the k value is. So you've got to find out how many standard deviations you can move from one to the other. So for this one, you're really just going from, you've got 90 here, you're going to a low score of 72 or a high range of 108, kind of keeping that in those numbers there. That really all you have to do is just figure out, and it should be the same either way, whether you go from 90 to 72 or 108 to 90. As long as you move from the mean to the lower end of the range they're giving you, or to the higher end of the range they're giving you, it should be the same way. So you've got 18 numbers that you're kind of moving between. Well, if the standard deviation is 6, that's telling you how many standard deviations that you have. So it basically, if you're going 18 in either direction from the mean, whether you go 18 down or 18 up, so basically you're moving 18 numbers either way, you've got to figure out how many standard deviations that is. Well, if it's 6, you're just going to take that number that you're moving in either direction and just divide that number by your standard deviation. So that tells you that your k value then would equal 3. All right, and then you can use the formula we had earlier. Just do the 1 minus 1 over k squared. That's 1 minus 1 over 9. So that's back in the exact same problem we had up here, which was 8 over 9. Now, in that particular problem, they didn't ask for a fraction of the numbers. They said change it to a percent. So that's one where you just change it to a percent. and should have been 88.89%. All right, let me give you one more example with that one, and that will wrap up 10.3. All right, same setup as the last one. We're in a certain distribution. The mean is 100. Standard deviation is 5. And then what they can do in the question is they can kind of word it a little differently, kind of so that they're looking at something else. What percent of the numbers are less than 90 or more than 110? Okay, so the initial setup of it is pretty much the same thing, that you have the mean of 100. We're looking at either 110 or we're looking at 90. So we're going 10 in either direction for this thing. Standard deviation is 5, so we're going to take the 5 divided into 10. So that's going to give us that the k value would equal 2. All right, and if you plug that into the formula, it's 1 minus 1 over 2 squared would be 4. So that would be 4/4 minus 3/4. Sorry, 4/4 minus 1/4 would be 3/4, which would be about 75%. Okay, now that number is everything that's between 90 and 110. And the question is saying what percent of the numbers are basically outside of that. How many are less than 90 or greater than 110? Well, if 75% is between 90 and 110, then we'll just say, all right, well, if that's the case of what's in between here, that means that 25% would have to be beyond that. So the 25% would be the numbers that are less than 90 or greater than 110. Okay, so with those, if you just don't get in too big a hurry, just make sure that you're reading it, because sometimes people kind of scan through and they'll see the two numbers here. That one, you just have to make sure that you're asking the question or answering the question that they're asking, because sometimes they'll say how many are between 90 and 110. In this case, they're saying how many are beyond, how many are less than 90, or how many are greater than 110. So you just have to kind of read and make sure of what it is that they're asking. Okay, so as far as section 3 goes, that is it for section 3. Okay. Let's do this, because I was going to, and I forgot to scan this in and just print it off. Well, I'll tell you what, let's see what we can do here.